Hello, going to talk about covalent bonding. Covalent bonding is a bonding of atoms. So if it happens if a single silicon atom shares its valence electron to another silicon atom. So like this one. So it shares its valence electron. So multiple silicon atom. So with this, it will strengthen the atom. So multiple silicon, so it shares with another valence electron. So the process is called covalent bonding. So the bonding of atoms happen if a single silicon shares its electron to another atom. In this situation, the atom is they have the same atom, which is silicon. So this type of material is categorized as intrinsic materials. Intrinsic materials because they are pure. They are all silicon atom. So no impurities are present in the bonding. So this atom is categorized as intrinsic materials. So intrinsic materials are those semiconductors that have been carefully refined to reduce the impurities to a very low level. So it's just essentially as pure as can be made available. So if it is pure, so it belongs to a intrinsic material. An example of intrinsic material is our silicon, and also germanium. So these are the two commonly used semiconductor material in the market, germanium and silicon. But the most commonly used is the silicon, since the abundant, so the planet is abundant with silicon. So if you refer to our canvas, so let's go to the energy levels and energy gap. So the more distant the electron from the nucleus, the higher the energy state, and any electron that has left its parent atom has a higher energy state than any electron in the atomic structure. So if you refer to the table, so if the energy gap, if this is the conduction band, so this is the valence band. So the energy required for a valence electron, if the energy gap is greater than 5 electron volt, also this is an insulator. So if the energy gap of a valence electron is higher, so it needs more energy in order to jump from valence band to the conduction band, so that is an insulator. But if in the conduction band, valence band, if the energy gap is equal to, so it depends on the semiconductor material. So if it is 1.1 electron volt, so that is for silicon, energy gap for germanium is 0.67 electron volt. Energy gap for the gas is 1.41 electron volt. So gas stands for gallium arsenide. So this is categorized as a semiconductor. Semiconductor. But if the conduction band and the valence band so narrow, the gap between the conduction and valence band is so narrow, so almost they overlaps, no? Meaning this is a conductor. So imagine if a silicon atom, if this is an atom, if this is a electron, this is the valence electron. So in order for this electron to jump to another atom, so it needs more energy. So if the energy is greater than 5 electron volts, so that is considered as an insulator. So insulator, so in our previous discussion, it will be categorized as insulator if the valence electron is greater than 4. So if valence electron is greater than 4, probably the energy gap needed for the valence electron in order to jump to the conduction band, it should be greater than 5 electron volt. But if it is a semiconductor, if it has 4 electron volts, so it needs this energy gap. But if this atom is a conductor, so it needs only less than or almost approximately equal to 0 energy to be at the conduction band. So since this is a conductor, so it's easy for this valence electron to jump to another atom. So if there's an intrinsic material, there's also a extrinsic materials. So the intrinsic material are pure materials, so no impurities. On the other hand, the extrinsic materials, so impurities are present. So there are two types of extrinsic material. The first one, so by definition, a semiconductor material that has been subjected to doping process. So doping. So if it is subjected with the doping process, so that is doping, doping. So it is called the extrinsic materials. So there are two kinds of extrinsic material. It can be N-type material and P-type materials. So in our previous discussion, so if we compare insulator, semiconductor, and a conductor, the only type of material that changes its characteristic is the semiconductor material. So semiconductor material, it can be insulator, it can be also a conductor. So N-type and P-type material are semiconductor devices which are doped with another impurities in order for the characteristic to change. So let's start with the N-type material. So in an N-type material, so it's either silicon or germanium. So this atom will be doped with another impurities. So these impurities are called pentavalent. So pentavalent meaning that is 5 valence electrons. So pentavalent are those atoms that has 5 valence electrons. So these elements or atoms that are pentavalent, so kani antimony, arsenic, and phosphorus. No, so this is phosphorus. So atoms that have 5 valence electrons are these 3. So antimony, arsenic, and phosphorus. So if this silicon atom doped with either these 3, antimony, arsenic, or phosphorus, so the semiconductor will become N-type material. So antimony, arsenic, and phosphorus have 5 valence electrons. So if you have, say for example, the antimony, so the symbol for antimony is Sb. So since the antimony has 5 valence electrons, so if you can see there, first electron 1, 2, 3, 4. The other one is the fifth. So nasa fifth dala, no? So since the silicon atom has only 4, so nasa the silicon. So silicon. So sharing of valence electrons. So etc. So nasa so this atom or this material has an excess of electron. So nasa excess of electrons. So since nasa excess of electron, so this is categorized as N-type material. So since N-type material are the majority carriers are electrons. Minority carriers are the holes. So this is minus and this is the plus. By the way, holes, so for example, if this is a silicon atom, this is an atom general, and nasa valence electron, and there's another atom here. If this valence electron jumps to another atom, it leaves a space. This space is called a hole, and this hole is yung charge is positive. So if this electron leaves its mother atom and jumps to another atom, this thing will leave a space, and that is called a hole, and that is a positive charge electron. So that is a hole. So if there is a flow of electrons, meaning if this electron jumps to another atom and then this atom jumps to another atom, it leaves again a hole here, and then it attracts another electron. So there's an electron flow. And this electron flow is what we call today as electric current. So meaning if there's an electron flow, there's an electric current. So in electronics, we'll just categorize a minus, that is electron, and then if it is a positive charge, that is a hole. Minus electron plus a hole. So that's why in N-type material, majority carriers are the electrons, minority carriers are the holes. And also, in order for the silicon to be an N-type material, you need a pentavalent atom. And you need to dupe a pentavalent atom in order for the silicon to be an N-type material. So nasa exist of electron. So mnemonics ani is, in order to memorize these pentavalent atoms, so phosphorus is PAA, so meaning that is PAA, no? PAA, phosphorus, arsenic, and antimony. So pentavalent atoms are also, so these atoms are also called the donor atoms. So since they have an excess of electrons, meaning they have the capability to donate an electrons. So since there's an excess of electrons. On the other hand, the p-type material, so in a p-type material, in order for the silicon to be in p-type, you need to do trivalent. So trivalent atoms. Trivalent atoms has 3 valence electrons. 3 valence electrons. So these atoms are 1, boron, indium, and gallium. So since these are trivalent materials, so say for example boron, so this B, so trivalent, it only has 3 valence electrons, so this is empty, so it will share its atom to a silicon semiconductor, and this one naputol. So if you have a space here, so since the boron has only 3 valence electrons, so nasa empty space, so this is considered as a hole. And since there's a hole, so there's an excess, this is one lacking electron. So if there's one lacking electron and an excess of holes, so therefore the majority carrier of p-type material are holes, the minority carrier are the electrons. So this trivalent or the p-type material are considered as the acceptor atoms. So since they are willing to accept atoms, since they are lacking man sila og electrons, you know, so they are lacking 1 electron, so that's why they are considered as acceptor atoms. They are willing to accept the excess electron.